All right, today we're jumping into a huge question in AI. We've got all these super powerful large language models, right? But how do we actually know if they're any good? It's a way trickier problem than you might think. Let's dig in.
So this is really the heart of the matter. When an LLM spits out an answer, whether it's a summary, a piece of code, you name it, how can you be sure it's actually right, or helpful, or even on topic? It's definitely not as simple as checking if 2 plus 2 equals 4.
And this slide, it's the perfect illustration of the problem. You know, a basic keyword search would probably score both of these answers pretty well, because they both mention Joe Biden. But you and I can see in a split second that Model B is completely, totally, laughably wrong. This is the challenge, understanding the actual meaning behind the words, not just matching the words themselves.
Okay, that brings us to our first section, the scoring problem. Let's really get into why measuring these models is so darn hard.
Think about it this way. Regular software is pretty straightforward. It's deterministic. You click a button and the exact same thing happens every single time. It's predictable. But language, oh man, language is messy. It's filled with nuance, context, and a bazillion different ways to say the same thing. There isn't just one single correct answer, and that makes trying to score it with a computer a real headache.
So what are the biggest hurdles we're up against? Well, first off, you could have people check every answer. That's kind of the gold standard, but it is incredibly slow and super expensive. Plus, different people might score the same answer in different ways. We've already seen that just matching keywords is a total failure. And those older metrics from the world of NLP, they just can't handle the kind of creative, open-ended stuff these new models produce. And here's the kicker. These models are so sensitive that sometimes just a tiny change, like an extra space in the prompt, can completely change the outcome. Wild, right?
So with all those problems, how did researchers even begin to tackle this? Let's take a look at some of the early, clever workarounds they came up with. Welcome to Section 2, the Researcher's Toolbox.
One of the first smart approaches was to use something called log likelihoods. Now, instead of asking the model to just write an answer, researchers would kind of flip the script. They'd ask the model, hey, given this question, how probable is it that you would generate this exact right answer? It's almost like asking the model to place a bet on which option it thinks is the winner. It gives us a little peek inside its statistical brain.
This technique is just perfect for things like multiple choice questions. It's a simple process. You give the model a question, along with a few possible answers, A, B, C, or D. Then you use those log likelihoods to figure out which answer the model thinks is the most likely. Whichever one gets the highest probability score, boom, that's what we count as the model's choice. It's a really sharp way to get around the whole messy business of grading open-ended text.
But, and this is the really crucial part, while this whole multiple choice thing is fast, it's cheap, and it stops the model from giving weird off-the-wall answers, it doesn't really test how these models work in the real world. I mean, think about it. You don't use a chatbot to take a quiz, right? No, we use them for these complex, back-and-forth conversations.
And that leads us right to Section 3. Enter the LLM-judge. This is where things get really modern and, honestly, a little bit mind-bending.
So somebody had this brilliant idea. What if the very best tool for evaluating the complex, nuanced language of a giant AI model is another giant AI model? I know it sounds almost circular, but think about it. Using an AI's greatest strength, its incredible grasp of language, to grade its own kind. Now, this LLM-as-a-judge idea usually comes in two main flavors. On the one hand, you can have a judge LLM just score a single answer on a scale, like rating its helpfulness from 1 to 5. Or you can set up a little showdown, a pairwise comparison. It's kind of like a taste test. You give the judge two different answers to the same prompt and simply ask, hey, which one of these is better? Now, you might be wondering, does this actually work? Well, just look at the data on this slide. It is fascinating. Research has found that powerful LLM judges, like GPT-4, agree with human judgments about 85% of the time. That's incredibly high. But get this, it's actually higher than the agreement between two different humans, which is only about 81%. This shows that using an LLM judge isn't just some cool idea, it's a legitimately effective and, most importantly, scalable way to do this. Okay, moving on to Section 4, making evals matter. So we've got all these cool methods, but how do we make sure that a high score actually means something for a real-world business?
This quote on the screen just hits the nail on the head. I mean, what's the point? Just measuring something for the sake of getting a score is an academic exercise. If you're building a real product, your evaluation has to be completely focused on the business outcome you're trying to achieve.
And this is where we need to draw a line between two different kinds of evaluation.
On one side, you've got your model evals. These are the big, general benchmarks that tell you how smart a model is overall. They're great for comparing the big players, like GPT-4 versus Claude 3. But for your project, what you really need are downstream evals. So for instance, if you're building a customer support chatbot, who cares if it can write a sonnet? You need to test it on one thing and one thing only: how well it resolves your customer's actual problems.
All right, Section 5, your evaluation playbook. Let's pull all of this together into a practical, step-by-step framework that you can actually go out and use.
It's a pretty simple 3-step framework. First, you define your business goal. What does success look like in the real world? Is it faster ticket resolution, happier customers? Step 2, break that goal down into specific tasks the model needs to do. Does it need to classify an email, pull out key information, or write a summary? And finally, step 3, you pick metrics that directly measure how well the model is doing those specific tasks. That way, everything from the model's score to your company's bottom line is all lined up.
And what's really cool is that you don't have to start from scratch. There are tons of great open source frameworks out there. You can see a few on the screen like DeepEval and Ragus. These give you all the tools and metrics you need to get started building powerful evaluation pipelines right away.
So getting a handle on LLM evaluation is absolutely essential for anyone building AI products that are actually useful and reliable. But as these models keep getting smarter, and as we rely more and more on AI to judge other AI, it leaves us with this final, really big question to chew on. As the judges themselves become more and more powerful, who judges the judge?